Hello everyone, thanks for coming to our talk. I'd like to present our paper, PolicyFlow, Interpreting Policy Diffusion in Context. Over the last year, we experienced an unprecedented time due to COVID-19. What actually changed our everyday lives was public policies, such as social restrictions and social distancing. However, we also see that there is a discrepancy in terms of how, when, what different countries and governments adopted such policies. You may ever be interested while listening or reading the news. Why do some states and countries require masks, but others don't? When you unfold it along the temporal dimension, we see more dynamic aspects on how policies spread over the regions. Then what is the underlying force behind such transmission of ideas, information, and policies? Some researchers try to speculate it with the perspectives that political actors are connected and compete or learn from each other, like they are forming a network. The approach here is that they are trying to infer such a network, get such a relationship, by looking at the event history of policy adoptions. But despite such advances in research, when we analyze large amounts of policies and relevant documents, it is highly complex and context dependent. One might be interested in asking such questions. How do such relationships differ in the specific context of interest? Who are the leaders or followers of the network and such relationship? Or how do we interpret the inferred network when the analysis is driven by an inference model? To answer those questions, our study supports interpretable diffusion pattern discovery in three aspects. First, we implement PolicyFlow, a visual analytic system that enables exploration and interaction in different contexts. Second, we propose a novel metrics-based visual representation for understanding policy diffusion over time and space, with introducing two concepts of diffusion pattern. To evaluate our system and support the tasks, we conducted comprehensive three studies with a variety of real-world political settings. To develop our system, we worked with domain experts in a year-long period to gather the feedback, and we ended up with four requirements as described here. Our system takes the specific setting of state policies in the United States. Our system supports overviewing diffusion patterns and filtering contexts in topical, temporal, and spatial dimensions. It also supports exploring the structural details for network and adoption sequences and facilitating the interpretation of inferred networks, which will be explained in detail later. The key underlying mechanism in our system is to infer diffusion network from given adoption sequences. Let me take a simple example here. We have a specific state policy P and a single adoption case where California adopted the policy P in 1971. When there are multiple adoption cases in chronological order, this is an adoption sequence for policy P. Then we can think of multiple sequences for a set of policies. Here, we want to capture the temporal dependency as a general diffusion pattern. For example, red states here precedes yellow states in three sequences out of four. Then we can interpret that California is likely to influence Virginia regarding these policies in the network. Here, we leverage a network inference method called netinfer algorithm to capture the general diffusion pattern. PolicyFlow is implemented based on the aforementioned requirements and underlying inference mechanism. In the initial load, users can overview the topical and categorical, spatial, and temporal dimensions of policies. These three views coordinate as filters as well, so users can select a set of policies or adoption cases. In the network view, users can explore the inferred network and also the structural details of general diffusion pattern. The nodes are highlighted with darker and lighter orange color for source and target states when mouse over it. Users can explore the details of a specific policy, but also explore other policies that are similar in terms of content and cascade. Policy inspection view is a metrics-based layout we propose for interpreting the general diffusion pattern. First, we introduced two concepts for interpretation purpose here, expected and deviant pattern. For example, look at the relationship between California as red and Virginia as yellow in the network. When we look at individual sequences, expected patterns are ones conforming to the relationship where influential states precede follower state in chronological order. On the other hand, deviant patterns are where the relationship is in reverse order. In our policy inspection view, those adoption case cases are presented as purple semicircles along the x and y axis by its adoption year and state. Those two expected Debian and Debian patterns are encoded with purple and pink color. Users can take a closer look at a specific adoption case by operating a semicircle, like here, Minnesota, Minnesota State in the example, and it is highlighted as yellow with the arrows to its source and target nodes. To evaluate our system, we conducted three kinds of evaluation in real-world political settings with two case studies, interviews with three domain experts, and user study with 15 non-expert participants. We present the first case study with demo. In the scenario, a policy analyst is interested in looking at abortion ban policies, specifically in the late 20th centuries in northeastern regions. In the system, she selected civil rights categories as the most relevant to abortion ban and the time period from 1970 to recent years. She also filtered the states by selecting northeastern region. She found that Connecticut had a greater influence than other states. She searched for abortion to look at relevant policies, and 18 policies appeared. She decided to take a look at the policy called Physicians Can Refuse to Do an Abortion. She was able to find that the most similar policies were in the same category, and the top one is the abortion ban related policy. When she checked the policy inspection view, she found the pattern that it was adopted repeatedly to many states within 10 years after initially adopted by New York State. She hovered to Pennsylvania, and the system highlighted that it was likely to be influenced by California, which also influenced other four states. Then she clicked on Attributes drop-down menu. Then it showed that total population and per capita income are the most related state attributes. And when she clicked it, Map and Network View allowed looking at the overview. In the first expert interview with the professor in public policy, we examined California Privacy Act 2018. The system has two relevant policies in domestic commerce category regarding the consumer information protection, and she was able to confirm the California's leading role as a pioneering state. In the interview, she mentioned two benefits of our system. First, the leading states like California can learn what will be the next possible states so that California best exert their influence on. And second, policymakers in the state and federal governments can anticipate how a policy will be accepted nationwide for the near future. But she also pointed out that the more complex interaction between state governments and federal system may affect the policy adoption as well, but it wasn't considered in the system. We conducted second interview with the professor in political science, and we discussed the school choice policy in the Trump administration. In the system, we looked at how general pattern in educational policies look like. As shown in the network, 5 Midwestern states were great influencers over other states, as expected. And a related policy called charter school law also showed a similar policy-specific pattern. He especially mentioned policy entrepreneurs such as think tanks, teaching professions, and grassroots groups who wants to promote such policies. He commented that they may be able to use the system to strategically plan how they allocate their resources to each state. In the user study, we found that the system was appreciated by the users in terms of usability, especially in terms of easy to use and understandable. And for effectiveness, all requirements were satisfying, but especially 3 participants mentioned that policy exploration in context was appealing and useful. Some feedback included that there is a steep learning curve for understanding network inference, and system may support more flexible policy filtering with keyword search. Thanks for listening to our talk. I'm happy to discuss if you have any questions.